Okay, welcome to Sunday's GCSE Help. Today's topics are proportion, quadratics and transformations. There's a couple of videos that I've done about some of those topics. The links are there. Also, the bottom link is for the page with all of the videos that are in the Facebook group that I made. So if you're a member of that group, you can go to that link and just see what there is to offer. There might be something that you find helpful. Okay, today's first question on proportion, and it says that m is directly proportional to r cubed. So we've got m and we've got r cubed. And when it says that they're directly proportional, it means there's a direct relationship between the two things. So the one thing equals something times the other, and we'll call that something k. So m equals something k times r cubed. And our job now is to find out what k is. We've got some information here. It says that when r equals 5, m equals 200. So if we put those numbers in, m is 200, and then if r is 5, r cubed is 5 times 5 times 5, which is 125. So 200 equals k times 125. And if we divide both sides by 125, then we can work out what k is. So k is 200 divided by 125. Let me just do a bit of quick mental arithmetic there. I should have had my calculator. It's the same as 400 divided by 250. 800 divided by 500, 1600 divided by 1000. It's 1.6, isn't it? So k is 1.6, remembering to use the English dot for a decimal. K is 1.6. So going back to the original thing that we wrote down, that means that the relationship between m and m and r cubed is that m is 1.6 times r cubed. So that's the important relationship between the two things. M equals 1.6 r cubed. And now that we've got that, we can work out the value of m when r equals 8. So I'll write over here, when r equals 8, m is going to be 1.6 times 8 cubed. So in other words, 1.6 times 8 times 8 times 8. And I wish I had my calculator to work out what that is. I'll just get that up on my computer screen. So this is very professional. 1.6 times 8 times 8 times 8, coming up in a minute, and that is, there we are, 819.2. So when r equals 8, m is 819.2. Second part of the question is, well, essentially the other way around. We've had to work out the value of m for a given value of r. Now we've got to work out the value of r for a given value of m. So we've got the basic relationship between the two things, because we worked that out in the first part. M equals 1.6 r cubed. And it says that m is 3125. So I can just put that one in. 3125 equals 1.6 times r cubed. Now I'm trying to get the r bit on its own, so I'm going to divide everything by 1.6. So on the left-hand side here, I need to work out 3,125 divided by 1.6. Time to get my calculator out again. 3125 divided by 1.6 is 1953.125. So that's what r cubed is. So r is going to be the cube root of that. cube root, the number which when multiplied by itself and multiplied again by itself gives you 1953.125. So again, getting onto my calculator for that, equals that to the power of and it's a nice neat 12.5. 12.5 is the cube root of that, so r equals 12.5. So let's write that in the answer space, r equals 12.5. Now make sure you know obviously where the cube root button is on your calculator. And a little tip here, if you haven't got a cube root button but you've got a power button, the cube root of something, let's say 8, the cube root of 8 is the same as that thing to the power of a third. So power of a third and cube root are the same thing, and of course that would give you 2. So that's just an aside. If you can't find the cube root button on your calculator, you can do it with the power button. Cube root and power of a third are the same thing. Okay, now next question about proportion, we've got inverse proportion. W is inversely proportional to x. So we've got two things, W and x, and they're not directly proportional, but they're inversely proportional, which means that one thing equals something divided by the other thing, so that as one of them increases, the other decreases. So the general form for that kind of relationship, as standard we use a k, but that really could be any letter. But the constant of proportion is called k. So W equals k divided by x. One thing equals something divided by the other thing. And our job is to find out what that k is so that we know what the relationship between W and x is. And we've got some information to help us with that. It says when W equals 6, x equals 20. So let's just write that in. When W equals 6 and x equals 20, we get 6 equals something, k, divided by 20. 6 equals k divided by 20, and we need to find out what k is. That's easy enough. To get rid of the fraction, the over 20, we just multiply both sides by 20. So k is 6 times 20, which is 120. So the relationship between k and x is that, that's right, i.e. W equals 120 divided by x. So that's the important equation that defines the relationship between the two variables, W and x. W is always 120 divided by x. Then it says work out the value of W when x equals 24. So when x equals 24, W is going to be 120 divided by 24, because we just plug x equals 24 into the relationship, into the equation that defines the relationship between W and x. So W equals 120 divided by 4, which is 5, of course. So when x equals 24, W equals 5. Okay, here's our next question on proportion. The first bit is testing you know really what proportion is about. So remember, if two things are directly proportional, it means that one thing is something times the other. There's a direct relationship between them. And as one gets bigger, the other gets bigger too. If two things are inversely proportional, that means that one thing is something divided by the other thing, so that as one of them gets bigger, the other will get smaller. So Here are four equations connecting y and x. K is a constant. Y equals k times x. Y equals something times x. So in other words, y and x are directly proportional. So match each equation to its statement. Y is directly proportional to x. That's the first one. Y equals k times x. The second one, y equals k divided by x. Y equals something divided by x, so they're inversely proportional, because in that relationship, as y gets bigger, x will get smaller, and vice versa. So the second one is y is inversely proportional to x. So on the list of statements here it is, y equals inversely proportional to x. That's the third one on the list. So I'll write the equation there, y equals k over x. On the third one, y equals kx squared, y equals something times x squared. So y and x squared are directly proportional to each other. So that's the second statement, y is directly proportional to x squared. Y equals kx squared, something times x squared. And then on the last one, y equals k divided by x squared. So y equals something divided by x squared, they're inversely proportional. So it's the last statement, y is inversely proportional to x squared. Y equals k over x squared. And then in part B, it says y is inversely proportional to x. So the relationship between them is y equals something divided by x. Y equals k over x. And it says that when x is 3, y is 8. So we can plug those values in. 8 equals something divided by 3. 8 equals k over 3. Well, that's enough to enable us to find out what k actually is, because we just need to multiply both sides of that by 3 to get rid of the fraction. And 8 times 3 is 24, so k is 24. So the relationship between y and x is that y equals 24 divided by x. And then the question is asking us to work out the value of y when x equals 5. So when x equals 5, y equals 24 divided by 5. And 24 divided by 5 is 4.8, so y equals 4.8 in this instance. Okay, today's first question about quadratics. Just a simple table to fill in. Complete the table of values for y equals x squared minus 4. So we've got the x values. Some of them are missing, so for the missing ones we've got to work out x squared minus 4. So 0 squared minus 4 is minus 4. 1 squared minus 4, so that's 1 squared is 1, and then 1 minus 4 is minus 3. And then 3 squared minus 4, so that's 9 minus 4, which is 5. So those are the missing values. And then we've got to use that table of values to make a graph for y equals x squared minus 4. So when x is minus 3, y is 5. Minus 3 and 5 is there. When x is minus 2, y is 0. So minus 2, 0 is here. When x is minus 1, y is minus 3. Minus 1, minus 3 is here. When x is 0, y is minus 4. So that's here. 1 minus 3, 1 minus 3 there. 2, 0, 2 and 0. And then 3, 5. 3 along and 5 up. So we've got to make the graph out of that. So you need a steady hand. This isn't very good, particularly what I'm doing it now. I'm doing it too quickly. Turn the paper around so that your hand is always inside the curve. At the very edges, it's almost straight, so I often cheat a bit and just ruler through there. So that's not brilliant, but it would probably get the marks. The key features of that, so nice and smooth. Mine's not particularly smooth around there. Nice and clean, so you don't want this thing where you're sort of sketching it and it looks a bit rough like that. At the bottom, it's absolutely flat, so it sort of gets shallower and shallower, completely flat at the bottom, and then starts to climb up again. So at the very bottom, it's level for a very short while. So we don't want this situation where you draw something that's sharp like that. Okay, so mine really, if I was doing this in pencil, I'd sort of flatten this out a bit at the bottom, like that. But of course, you don't want this situation where you're doing this very rough sketch in pen, trying to get it right. So I do it in pencil first, which I haven't got the time to do for this, and then pen it in afterwards. Okay, the second part of this question then. Draw the graph of y equals 2 on the grid opposite, which was that, for values of x from -3 to 3. Well, y equals 2 is a straight line. You're used to straight lines having the format y equals something x plus something, where the plus number on the end is where it cuts, and the m number, the number in front of x, is the gradient, how steep it is. This is a bit different because it just says y equals 2. So when you get a question about a straight line and it just says y equals something or x equals something, that's just a horizontal or vertical line. So in the case of y equals 2, y is just the straight horizontal line of all of the values where the y coordinate is 2. So there it is, y equals 2, 1 mark for that line. Write down the x coordinates, it says, of the points of intersection of the two graphs. Okay, so the two graphs meet kind of here at about 2.4 and around here at, well, if I'd drawn this perfectly symmetrically, they should meet at plus and minus the same kind of thing. So kind of minus 2.4. You know what I can do, because I'm a mathematician, I can actually work this out exactly, because where they meet, x squared minus 4 will be 2, will be the same as the y values will be the same on both the curve and the line where they meet. X squared will be 6, so x will be the square root of 6, which, if I get my calculator, let's just, words with friends, calculator, square root of 6 is 2.45, just about. Okay, so if you do it absolutely perfectly, it will be plus and minus 2.45 where they meet. But you're getting the marks for doing that from the graph and not from being clever and solving the equation. Okay, so the x coordinates of the points of intersection where the two graphs meet are 2.5 and minus 2.5. It's just asking you for the x coordinate and not the full xy coordinate. So 2.45 I decided it was, didn't I? 2.45 and minus 2.45. And I must, of course, remember to use a dot for a decimal on the GCSE. 2.45 and minus 2.45. And that was that question, which was question 2 from the June 2012 paper. Okay, so the next question about quadratics is just simply solving an equation. Now it's 3x squared plus 4x minus 10 equals 0. Now that's useful because it's in the normal form that we expect a quadratic equation to be in. Something x squared plus something x plus something else equals 0. If we got one where it wasn't equal to 0, then we would have to rearrange it, to add or subtract something from both sides so that it was in that form. So we want a quadratic equation to be in the form something x squared plus something x plus something else equals 0, so that we can use the formula. Now the formula is not something you have to learn. It's on the formula sheet at the front of the exam paper, or just inside the front of the exam paper. And the formula is x equals minus b plus or minus the square root of b squared minus 4ac, that's 4 times a times c, all of that divided by, if I can get this the right way around, there it goes, all of that divided by 2a, 2 times a. Now the a, b and c in this are the amounts of x squared, x, and a constant number on the end in the thing we're trying to solve. So a is 3 because there are 3x squared. B equals 4 because there's 4x, and then we've got minus 10 on the end, so C equals minus 10. So we've got to put those numbers into this formula. So x equals minus b, so that's minus 4 plus or minus, the plus or minus is because we're going to get two solutions, the square root of 4 squared minus 4 times a, which is 3, 4 times 3, times c, which is minus 10. So it's the square root of all of that, all divided by 2a. So all divided by 2 times 3. So we need to tidy that up a bit. So I'm going to try and tidy up the square root a bit. So I've got minus 4 plus or minus the square root of 4 squared is 16, and then minus, and then 4 times 3 is 12, times minus 10 makes minus 120. So I get minus minus. And these things are notoriously difficult with regard to minuses. People often make mistakes and lose a minus somewhere and get the wrong answer because they haven't kept track of all the minuses. And then on the bottom I've got 2 times 3 is 6. Okay, so I've got x equals minus 4 plus or minus the square root of 16 minus 120 makes plus, so the square root of 136, and that's all divided by 6. Now, the square root of 136 is something you'll need your calculator for. So 11.66 just about. 11.66 just about. So x is minus 4 plus or minus 11.66 all divided by 6. So that the plus and minus gives you two separate solutions that you need to work out. So minus 4 plus 11.6 is 7.66. So x equals 7.66 divided by 6, or minus 4 minus 11.66 makes minus 15.66. So it's 7.66 divided by 6, or minus 15.66 divided by 6. I don't know whether you can hear my 3-year-old in the background there. I'll just try and get this finished before he comes. So 7.66 divided by 6 equals just about 1.28. Hello, Sammy.
I need the paper.
You need some paper. Okay. There you are.
Oh, okay.
You're welcome. Yeah. 15.66 divided by 6, 2.61, and that's minus. So minus 2.61. So.
They need to go downstairs now.
Just a minute, Sammy. And actually, I was supposed to give my answers to 2 significant figures. I've done them to 2 decimal places. If I do them to 2 significant figures, that's 1.3. The 1 and the 3 are 2 significant figures, or minus 2.6. The 2 and the 6 are 2 significant figures. So my final answer is that x equals 1.3 or minus 2.6. Okay, the next couple of questions about quadratics are from November 2012. Now, the first one says, solve the equation x squared minus 5 equals 0. Well, the fact that it's equal to 0 is helpful to us because we like quadratic equations to be set as something equal to 0. So we can use the formula. And we could use the formula for this one. So we've got x squared minus 5 equals 0. So that's the same as having, well, x squared is like 1x squared. How many x's have we got? No x's, so plus 0x, and then minus 5 on the end. So we could set this up with a is 1 because we've got 1x squared, b is 0 because we've got 0x, and c is minus 5 because we've got minus 5 on the end. We could do that and then put all of those numbers into the formula. X equals minus b plus or minus square root b squared minus 4ac all over 2a. But actually, there's an easier way to do that. Because the thing we've got here only has one x squared term in it, now normally you have like an x squared and an x term in a quadratic equation, but because this only has an x squared in it, then it's easy to manipulate it just by adding and subtracting and doing other things to both sides. So x squared minus 5 equals 0. Add 5 to both sides. X squared equals 5. And if x squared equals 5, x is the square root of 5. Get your calculator out and do the square root of 5. 2.2, I've got to give my answer to 1 decimal place. So 2.23 rounds down to 2.2. So answer x equals 2.2. It wants 2 answers. Well, a square root can be plus or minus because plus times plus makes plus and minus times minus makes plus. So the square root of 5 is not only 2.2 something, but also minus 2.2, because minus 2.2, that number, multiplied by itself will make 5 as well. So that was a quadratic equation, but we didn't need to use the quadratic formula to solve it because unlike most quadratic equations that you'll meet in exams, it only had one term that had an x in it. Okay, question 9 is also about quadratic equations, and it's a bit more difficult. It shows a rectangle, and the area of the rectangle is 90 centimeters squared. So that's 90. And it tells us that the sides are x plus 4 and x minus 5. And of course, you know that the way of getting the area of a rectangle is to multiply the sides together. So if we multiply the sides together, x plus 4 times x minus 5, that should give the area of the rectangle, and we know that that area is 90. So the two sides multiplied together make 90. So x plus 4 times x minus 5, we need to multiply that out. Remember, when you're multiplying two brackets together, it's everything in the first times everything in the second. So x times x gives me x squared. X times minus 5 gives me minus 5x. 4 times this x gives me plus 4x. And 4 times minus 5 gives me minus 20. So x squared minus 5x plus 4x minus 20 equals 90. I've got a minus 5x and a plus 4x. I can put those together to make a single x term, minus x, or minus 1x. Minus 20 equals 90. Now I would like this to be arranged as something equal to 0, because then I can use the quadratic formula. So I'm going to take the 90 away from both sides. So take 90 away from there to give me 0. Then I've got to take 90 away from the other side. So instead of minus 20, that will be minus 110 on the end. So x squared minus x minus 110 equals 0. Now, I could use the quadratic formula on that. So I could say a is 1 because we've got 1x squared. B is minus 1 because we've got minus 1x. And C is minus 110 because we've got minus 110 on the end. So I could put all of those numbers into this formula, and it would tell me what x and y are. There's not much space here, and it's only, well, 5 marks is quite a lot of marks. So if you want to use the formula, you can do that, and you'll have to come up here with the working, and you'll be quite cramped for space. I've spotted that that's something that factorizes quite easily. If you remember, when you're factorizing quadratic equations, you're looking for factors of something that add up to something else. So I'm looking for factors of minus 110 that add up to minus 1 because I've got minus 1x. And I'm immediately thinking, well, 11 times 10 is something that gives me 110, and there's only one difference between 11 and 10, so I can do something with that gives me 1. So because it's minus 110, it's got to be, one of them's got to be plus and one of them's got to be minus, so that when we multiply them together we get the minus 110. And if we make it minus 11 and plus 10, so 10 times minus 11 gives us the minus 110, and 10 plus 10 and minus 11 together make minus 1, and we've got minus 1x. So 10 and minus 11 are factors of minus 110 that add together to give minus 1, which is what we're looking for in factorizing it. So we can do this by factorization, or if you did it by sticking all of the numbers into the formula, you would get to the same answer by a longer route if you didn't make any mistakes. So in terms of a quadratic equation, this thing has two solutions, which are x equals minus 10 or x equals 11, because to make the whole thing 0, either of the brackets has to be 0. So if x is 11, that will make this bracket 0. And if x is minus 10, that will make this bracket 0. So the solution is x equals minus 10 or plus 11 to make either of the brackets 0, to make the whole thing 0. In the context of this problem, x can't be minus 10 because you can't have a negative side of a rectangle. We're only dealing in positive numbers here. So the only one that makes sense in the context of the problem is x equals 11 centimeters. So the value of x is 11 centimeters. We can check that. If x is 11, then this side of the rectangle will be 15, and this side of the rectangle will be 6, and 15 times 6 does indeed make 90. X equals minus 10 would give you two sides of the rectangle that multiply together to give 90 as well, but they would be negative numbers, so it wouldn't make sense in context. So you can do that either way, either by the factorization route or using the formula route, and you'll get the 5 marks. Using the formula, it's probably a bit more work. You have to write more down. Using the factorization, you probably need to be a bit smarter to spot it. So it's less work if you can do it, but maybe it's a bit harder to do. Okay, today's last quadratics question, and it's a straightforward solving something using the quadratic formula. It even tells you to do that. It tells you what the formula is on the sheet at the beginning of the exam paper. So the formula is x equals minus b plus or minus, let's just write this down, x equals minus b plus or minus square root b squared minus 4ac. So it's the square root of all of that, all divided by 2a, 2 times a, and the a, b, and c are 6. A equals 6, b equals 5, and c equals minus 3, because in the equation we're solving, there are 6x squared, 5x's, and minus 3 on the end. And the whole thing is set to 0. That's important. If it wasn't equal to 0, we'd have to do something to both sides so that we had something that was equal to 0. So we've got to put those numbers a, b, and c into the formula here. And of course the important thing is to be careful with the minus numbers. So let's just go down here. Minus b, so that's minus 5, plus or minus the square root of b squared, so that's 5 squared, which is 25, minus 4ac, so 4 times a, which is 6, times c, which is minus 3, so it's the square root of all of that, divided by 2a, divided by 2 times 6. Okay, so tidy that up a bit. So that's minus 5 plus or minus the square root of 25. We've got a minus that's there in the formula, and then 4 times 6 times minus 3 gives us another minus. So 4 times 6 is 24, and that times 3 is 72, so that makes minus 72. So in the square root we've got 25 minus minus 72, all divided by 2 times 6 is 12. Okay, so minus minus makes plus, so that's the same as minus 5 plus or minus the square root of 97, all divided by 12. Okay, time to get the calculator out. Square root of 97, 97 square root. I'll round that to, what shall I round that to? For the moment, I'll go to 3 decimal places so that I can be confident of my final answer to 2 decimal places. So 9.84, and then I'll round that to 9. So I'm going to go up here. X equals minus 5 plus or minus 9.849 divided by 12. And in fact, if I'm smart, I can keep this number in the memory of my calculator. so that I can use the exact value. And if you don't mess that up, like I did the first time I did it, then you get x equals 2.42 or minus 1.24 to 2 decimal places. Okay, the next batch of questions concerns graph transformations, so things like rotations, reflections, enlargements, that sort of thing. And this question here, which is question 4 from June 2012, involves a graph transformation, but it's really testing something else. So let's have a look at it. It says, work out the area of the shape after an enlargement of scale factor 2. So I could do a scale factor 2 enlargement. It doesn't say use a particular center of enlargement, so I could just draw everything twice as long and see what happens. So instead of 2 along the top, it'll be 4 along the top. Instead of 1 down here, it'll be 2 down. Instead of 1 across, it will be 2 across. 4, 2, 2. I'm doing this fairly roughly because the points aren't really for the diagram, but for the math that goes with it. So if you didn't know better, I mean, you could just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares in that. That's 12 centimeters squared. Let's assume these are, well, they are centimeters because it tells us here. So that's 12 centimeters squared. And I could count all the squares in this. 1, 2, 3, 4, blah, 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 48. 48 centimeters squared. So the area of the shape is 48 centimeters squared. That's a kind of long way of doing it. The smart way of doing this is to know that if the lengths increase by times 2, then the areas will increase by times 2 times 2, because you get the areas from lengths times lengths. So the smart way to do this is to say 12 times 2 times 2, 48. So doubling the lengths makes the areas increase by not 2 times, but 2 times 2 times. And then if we were going into 3 dimensions and this was some kind of a box, then doubling all of the lengths would make the box 8 times bigger, because it would get bigger by 2 times in this direction, 2 times in this direction, and 2 times in the third direction. 2 times 2 times 2 would be 8. So doubling the length of a box makes the area of the sides 4 times bigger and the volume of the whole thing's 8 times bigger. So this wasn't really a question about graph transformations. It was really a question about knowing that. Okay, the next question is about rotations. It says rotate the triangle through 90 degrees clockwise about 0, 1. So that's this point that I've marked here, 0, 1. So it's as if the whole shape is going to turn, as if there's like a nail or something in that point and it's pivoted around that point. So you can sort of imagine how that's going to swing round. Now there's a couple of ways you could do this. There's the long way with a compass, where you get your compass point on the center of rotation and then get your compass pencil on each of the points and draw an arc as it turns around. So it'll be something, go around something like that. And it'll then you measure the 90 degrees in here at the center of rotation. So you turn it until it's gone through 90 degrees here, and then the point ends up there. So you could do that with each of the 3 points with an angle measurer and a compass. But actually, it's not good maths. But there is the cheaty way of doing it, where you just trace it like that on a bit of tracing paper, which you are permitted in the exam, and then you put your pencil in the point that it's going to turn around, and round it goes, and you can see exactly where it's supposed to end up. So having done that, you can just mark the points in where it ends up. One point stays the same, and then one goes here, one goes here, as we saw doing it with the compass. And there it goes, 90 degrees clockwise. So clockwise in the direction that a clock goes, in other words, 90 degrees. Now these exam questions, they're quite often 90 degrees, and because the graph axes are at 90 degrees to each other, that means that everything should land up on an exact point. And if you've got the right kind of brain, you can sort of just visualize anyway exactly where those points are all going to end up if you turn them through 90 degrees. But if you haven't, and not everybody has, then you've got the tracing paper. You can do it that way, do it that way, or of course you can do it properly with a compass and an angle measure, but it's only 2 marks, and you'll get the 2 marks for the thing in the right place. Okay, our next exam question is from November 2012, and it says, reflect the triangle in the line x equals 1. So of course you've got to know what the line x equals 1 is. So if you look at the x-axis, x is 1 here, and x equals 1 is the line of all points where the x value is 1. So it's this vertical line here, there's the line x equals 1. If you look at the xy coordinates of all of the points on that graph, then the x coordinate is always 1. 0, 1, 1, 1, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. The x coordinate is always 1. It's the line of points where the x coordinate is always 1. So it says reflect the triangle in the line x equals 1. So that's our mirror line. Put an M for mirror if you like, or not. And you've got to imagine that flipping over. Now, with these ones where they're just straight lines that are parallel to the axes, I was about to say it's quite easy, but as you can see, I've just put that in the wrong place, haven't I? I've gone too far. So let's pretend I didn't do that. And it goes up to here. And there's the reflection over there. I would, of course, in an exam situation, do this in pencil and rub out my mistake, but hopefully you'll forgive that. If you're not very confident of that, or if you get something where the mirror line is like a diagonal line and you're a bit unsure, then you can always do it the cheaty way. So I've got my mirror line here. I'll draw that on my tracing paper. Boom, 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 dotted line. And I'll draw the original here. And then just to check I've got it right, I can flip this over and put my mirror line in the same place, and then you can see that my reflection is indeed where it should be. So that's part A of this question. Part B asks me to do a rotation. So rotate the triangle through 180 degrees about the origin. The origin means the center of the graph, the point 0, 0. So rotate the triangle through 180 degrees. So I could do the whole thing of getting my compass point at the center of rotation, 0, 0, and then getting the pencil point of my compass on each point, rotating it through 180 degrees. Doesn't matter whether it's clockwise or anti-clockwise, because 180 degrees is just half a turn round either way. So I could do all the thing with angle measurers and compasses, or I could do it the cheaty way, get a bit of tracing paper, so a little mark for the point I'm going to rotate it around, the origin, 0, 0, which is my center of rotation for this. draw the original shape, and then because these squares are have 90 degree angles in them, it's quite easy to see where 180 degrees is. So a little turn around there until it meets up with the lines on the graph over there. That's 90 degrees, and then a bit more takes it around 180 degrees. So you can cheat a bit to, it's not cheating, it's perfectly well allowed to figure out where the graph is going to go, and it's going to go over there. So I can just lift this up a bit and put those points in. And my new triangle goes there. Now it's only 2 marks, so I think that it's perfectly acceptable that you do it this way, because doing it the long way with a compass and an angle measurer is quite a lot of work for 2 marks, and you're earning the 2 marks for knowing what it's asking you to do there, rotate, origin, and then actually getting the thing in the right place. That is in itself 2 marks worth, so don't feel guilty about using the tracing paper. Okay, our final question today is from March 2013. It says, translate the T shape so that point A moves to point B. Translate means to just shift it. So there's the corner A going to B, and then 3 along is the top right corner. 2 down, sorry, 1 down, 1 in. So it's essentially just 1 mark for copying the same shape in a different place. Shade it in if you want, but there's no marks for artistic merit. So 1 mark just for that. Describe the translation. Okay, well, it's been translated as they said. They gave you the word for that. So they've given you the terminology: translate, translation. It is a translation by, well, how's it moved? It's moved, well, A's moved 1, 2, 3, 4, 5 units to the 5 units to the right, and 1, 2, 3, 4, 5, 6 units down, and 6 units down. And I don't know if you can hear my son in the background. Just a moment, Sammy. Okay, so 5 to the right, that's considered the positive direction, and 6 down, that's sort of considered the negative direction. So we can say, if we want to be really clever, i.e. by the shift vector 5 minus 6. So that's a vector that describes the movement. Everything's moved by 5 to the right and 6 down. 5 minus 6. That's a vector, not a fraction. So it doesn't have a line in between it like a fraction. It's just telling you how something's moved in the X and the Y direction. So that should be enough for the 2 marks for that. Okay, on Monday's session tomorrow, I will be going through the questions from the June 2012 paper that we haven't already covered in the previous videos. So all the remaining questions from that paper in the next session.